A warm welcome to all the viewers. In this session, I'm going to particularly discuss about how you can easily assess structural model in Onyx SEM, draw a model in Onyx SEM to understand the relationship between the variables, and then do the assessment in lavaan package of R via simple script, which I'm going to tell you. So stay tuned, keep watching. First, we need to understand what are the parameters to assess structural model, especially when the model is reflective in nature. So the first step is we assess the parameter estimates. We ensure that standard errors are reasonable and there are no negative variances, which are also known as Haywood cases. What causes a Haywood case? We must know that a sample size which is too small, it affects the statistical estimator as it does not have enough data to stable out, leading to wild, unstable parameter estimates. Under identification, if you have tried to estimate more parameters than your data allows, example, you tried to estimate a latent construct with only two indicators without imposing the constraints. So that is why I recommended in my previous video also that each of the latent variable must have at least three indicators. Outliers or extreme normality. Severe skewness, kurtosis, or extreme data points can distort the covariance matrix. And structural misspecification. The model which you specified, the model which you draw, does not match in reality. You might have omitted an important path or forced a variable into a factor where it doesn't belong. So these are the common reasons why Haywood cases arise. We must inspect them to see whether our model is okay and correct to move ahead with the assessment or not. Second, we need to evaluate the global model fit just like we did in measurement model assessment. You might like to go back and check my previous video on my measurement model assessment as well. Here again, we will check the chi-square, a non-significant p-value, which is desirable, but it is quite sensitive to sample size. So most of the times this is not achievable, that a p-value greater than 0.05 is got, even in IBM SPSS AMOS. Then RMSEA value should be less than 0.05, CFI and TLI should be preferably more than 0.90, SRMR should be less than 0.08. Then you come onto the structural model assessment. You check on the path significance, check if your hypothesized paths are statistically significant. That means the p-value is less than 0.05. And the R square assessment, check the practical strength of the model. So for an instance, if you go and get the R square value of 0.62, it means 62% of variance in DV dependent variable is explained by the combination of all the independent variables in the model. The threshold is if it is 0.25, you call it a weak, 0.50 moderate, and 0.75 is strong. So it signifies how much your independent variables are capable of explaining the variance in the dependent variable. That makes your model much stronger. Now let us dive into R and see what are the script which we need to type in to get the results and assess the structural model in lavaan package. So here we are in our R. So the first step is, as I told you in my previous video also, I need to activate lavaan. So I'm going to tell you all the steps one by one so that there's no difficulty. Then I need to activate the SEM tools package, which is already installed. I press enter. Now this is activated. lavaan is activated and SEM tools is activated. What next? I need to import my data. So the command is, if I have a CSV data, I just need to put this command, press enter, and it will ask me for the data source. So this window pops up. I go to my data source. This is the CSV data sheet. You see the model data is loaded. 204 observations of 25 variables, right? It is over here. Now what next I need to do? I need to set the seed. Why to set the seed? Use a fixed seed for Bootstrap so that the results remain exactly the same time every time you run it. So we are setting the seed, fixing the seed so that the bootstrap results which we are going to generate for structural model assessment remain the same every time we generate it. Otherwise, if we go for random seeding, the results might differ a little. I press enter, the command gets executed. Next, I have to put in this command. So this is the command. Structural model. I have defined the structural model having measurement model details as well as structural model details. You see here FQ, CA, SQ, VM and BI. These are my 5 variables, 5 latent variables, out of which the first 4 are independent variables, right? So they are expressing their influence upon behavioral intention, which is the dependent variable. In structural model, I specify that BI is influenced by a combination of food quality, cultural authenticity, service quality, and value for money. If I go into Onyx, let me show you how this model looks like. This was the measurement model having all 5 latent variables. This is food quality. This is value for money. This is cultural authenticity. You see here CA. This is service quality. And this is the dependent variable BI. Now, when I was doing a measurement model assessment, I drew covariances path between all of these latent variables. Now I am doing structural model assessment. So what I need to do? I need to draw in the specific path which I want to assess for the relationship between independent variable and the dependent variable. So what should be, how it should be done? First, I erase these paths. So delete path like this. I delete the covariances path. This is the way I delete it. And now I will press right button 1, 2, delete this covariance path also. Right click and put all of these 4 onto my dependent variable. So I am trying to tell that I am going to predict the influence of all these 4 independent variables upon my dependent variable. It is the case of multiple linear regression. So same like this model is used to explain so that you understand how my concept looks like. This is the model. So in R, what I did was I specified the measurement model and then I specified the structural model, saying that BI is influenced by all 4 latent variables. Now I press enter and next I put the structural command. So this is the structural command I put and press enter. Now the command will get executed. Before that, now I put the bootstrapping command because I've already fixed the seed. You see we have fixed the seed, so no need to put the seed setting again in this bootstrapping command. And I copy the bootstrapping command and I put it over here and press enter. Now you see a red button comes up over here, stop. So this means R is calculating, R is doing the calculation upon 5,000 bootstrap samples which we have specified over here. The minimum recommended is 5,000 bootstrap samples. So it is doing the calculation and will give us the results in some time. The command got executed and it says 4 bootstrap runs resulted in non-admissible solutions. Don't worry about this because you ran 5,000 bootstrap samples out of which 4 did not run. So sometimes this message comes, don't worry about this. We will go ahead and see what to do next. So once this is done, I'm going to display the results using this command, which will also display me the R square value. So I just put this command, press enter and get the results. You see R square value. What is the effect of these latent variables upon the dependent variable BI? This is 0.419. So if we go back to our slide, what do we see? That 0.419, the effect is weak. 0.50 moderate. So it is a weak effect. 0.25 to 0.49 is weak. 0.419 means 41.9% of the variance in dependent variable is explained by the combination of these four latent variables: food quality, cultural authenticity, service quality, and value for money. Now, what do we see next? We got all the results which we saw in measurement model assessment as well. Then we check the regression. So we come to this regression to check the path. But before checking the regression, we must go to the model fit measures. First, we see the chi-square. So chi-square statistic is 360.617. Degrees of freedom is 160. If you divide 360 by 160, it comes out to be somewhere around 2 point something, which is okay. Model test baseline. So we don't have to see the model test baseline model. We have to see the model test user model. Then we go to look at CFI greater than 0.9. Okay. TLI should also be greater than 0.9, but it is 0.898 in this case. Next, we see the RMSEA. It has to be less than 0.08. It is 0.078 in this case, which is okay. SRMR, which has to be less than 0.08. It is 0.061 in this case. So this is well and good. Now, once model fit is checked and you find all the indices okay, you have checked the chi-square by DF value, you have checked the RMSEA, CFI, TLI, and SRMR value. This is all okay. Then you have already assessed the factor loadings. They are all above 0.6 as we see in the measurement model. So no need to see them again. Then we go to the regressions. So when we look at regression, we see that BI is affected by food quality, cultural authenticity, service quality, and value for money as it was drawn by us in the model. In ONX also, you see 1, 2, 3, 4, 4 latent variables, independent variables expressing their influence upon the dependent variable. So we see that food quality, the standardized path coefficient is 0.148, cultural authenticity 0.228, service quality 0.387, and value for money 0.053. Are these path coefficients significant? So here what you get is a p-value. We want to check the bootstrap results. So how to check the bootstrap results? Confidence interval results. I'll show you. We just have to give one command which will show us the bootstrap results. So this is the bootstrap results. You see food quality upon BI, CA upon BI, service quality upon BI, VM upon BI. So the standardized path coefficient 0.148, 0.054. Is it significant or not? It should be less than 0.05, right? But since we have bootstrapped using percentile bootstrap method, you see here we specified percentile bootstrap method, which is preferred and which is usually recommended for bootstrapping. We have to look at confidence interval upper and lower. If 0 falls in between, that means it is insignificant. In this case, the lower confidence interval is 0.014 and upper is 0.442. So 0 does not fall in between. That means this path coefficient is significant, though it contradicts with the value of p. P value is 0.054. So we will report this lower confidence interval and upper confidence interval since we have been seeing the bootstrapped results for now. See the influence of cultural authenticity upon BI. 0.228 is the path coefficient. Is it significant? Yes. P value is less than 0.05. It's 0.035. Service quality less than 0.05. And P value for value for money, influence upon behavioral intention, insignificant, right? 0.547. What do the bootstrapping results tell us? Yes, now you see here 0 falls in between the lower confidence interval, CI is confidence interval, and the upper confidence interval. Here it is minus 0.169 and here it is 0.292. 0 falls in between, that means it is insignificant. So this result of bootstrapping coincides, supports the p-value result. So this is how you do the assessment and you report the results. You can report them in this format like this. So this is the correct interpretation of your structural paths. You mention the beta, that is path coefficient, standardized path coefficient. You mention the p-value, and then you mention the 95% bootstrap confidence interval lower limit 0.014, upper limit 0.442, and then you mention whether it's a borderline weak case, significant, significant, non-significant, right? Depending upon the bootstrap confidence interval and p-values interpretation. So friends, this is how easily you can do the structural model assessment in lavaan package of R. I hope the video was quite informative and useful for you, and you will definitely share it with your friends and faculty colleagues. See you next time with some more informative content. Till then, thanks a lot.